Thank you, everyone, for joining. Hello and welcome. My name is Rick. I'm with Epic Games, and I'm joined by Thomas from 2K.
Hello.
Today, we're here to talk about cheating. We are going to specifically talk quite a bit about how we use Epic Online Services to deal with cheating. We will also get into some game-specific anti-cheat efforts we have for Fortnite and for some of 2K's work as well. So let's dive in. The agenda is really simple for today. 3 bullet points, starting with talking about what the Epic Online Services moderation actually includes. Then we'll talk about Fortnite's approach and challenges. I'll talk about that. And then Thomas will get into some of 2K's approach and challenges as well. Oops, wrong way. So a first big question, what is Epic Online Services? We'll use the abbreviation EOS a lot today. I like to try and think about EOS as being kind of like a game engine, except it's for online services. What do I mean by that? I mean, it should hopefully save you from needing to reinvent the wheel too much with online services. There's a lot of things that online games repeatedly need. So hopefully you can take our implementations of those and plug them in versus having to reinvent them every time. These services are available to developers on any game engine and on any store, so kind of like UE. If you use EOS, you're not locked into other Epic stuff. You can use whatever tools are appropriate for your case. A lot of the EOS services are used by Fortnite. All of these services are free to get started with. There's a little bit of a caveat with anti-cheat, having some paid features that we'll talk about soon. So let's go ahead and take a high-level look at some of the services included. So here are the EOS services right now. There are a bunch of them. All of these services work across all the major platforms, PC, console, and mobile. Anti-cheat, again, is a bit of an exception in that for the protection, it is PC only. That means Windows, Linux, and Mac. However, for purposes of this talk, we're going to be focusing really heavily on Windows. That's where most of the PC players are and where most of the cheating action happens as well. On this slide on the right side, in purple, these services require players to have an Epic Games account. They're more like social-oriented things. On the left side of the slide, the blue and the orange, they do not require players to have an Epic Games account. You'll notice highlighted in orange, the moderation services are in that category. So they don't require players to have an an Epic Games account. And for more info on EOS this week, my colleague Khan's going to be giving a presentation tomorrow at 2 o'clock where he talks about Epic Online Services for mobile. That's not going to be including anti-cheat, of course, but that'll talk a lot more about the other EOS services. So please do check that out. Now let's go ahead and dive into moderation services. So moderation services, as we saw in the previous slide, we have 3 things bucketed there right now. One of the biggest one and the most complex one of these 3 is anti-cheat. We also call that easy anti-cheat. It's the same thing. That's a brand that we still use that predates that being part of Epic. But basically, the purpose of that service is to prevent and detect cheats for online multiplayer games. There's a lot of complexity that goes into it. We'll talk about it more today. In addition to that, there are a few sort of lighter weight services that can be used with or without anti-cheat. First one being player sanctions and appeals. So the idea there is to keep track of player account sanctions and things like that. Restrictions, that is, those can be sourced from anti-cheat or they can be for some other reason. So for example, if you maybe have players that are spamming voice chat or something like that and you want to create a sanction to block them from using voice chat for a little while, that's an example use case for sanctions that is outside of anti-cheat. We also have support for appeals in there so that you can let players appeal their sanctions, and you can have like a kind of pre-built web UI to deal with that yourselves. The other service is player reports. So the idea there is that if I'm a player and I see someone else who's doing something bad, I should be able to report them. And again, this includes cheating, but is not limited to cheating. So you can accept reports for other reasons if you like. But for cheating, it's very important. And we'll talk a lot more about that later too. So how do these things relate to each other? Basically, if you have a game where cheating is a concern, we recommend using all 3 of these together. They're very complementary with each other. And I want to actually go ahead and highlight the player reports aspect. We often have cases where we work with developers who maybe didn't think about doing player reports early on in their game's development, and then they get to like a later post-release phase, and it would be very valuable for them to have it, but it's difficult. So I would recommend thinking about player reports early on. Think about like having UI elements for that and all of that so that you can get that data. It's very critical for anti-cheat purposes and very helpful for other things too. Okay, so let's recap on everything so far. Anti-cheat reports and sanctions, the moderation services do not require an Epic Games account. For players, you don't have to make them create a new account or anything. If you're using Unity and Steam, that's totally fine. You don't have to ask your players to do anything new. You can get started with all of these services for free. Caveat again with anti-cheat, we have additional paid features. This is particularly for things where it's not sustainable for us to do them for free for everyone, like having human analysts look at your game in particular. We can't do that sustainably across 1,000 free titles. So for more info on all of this, my colleague Seb gave a great talk at GDC a couple months ago, excuse me, where he talked about a lot more detail of how to use the SDK, a lot of code samples, a lot of good pro tips about common pitfalls and things like that. I encourage you to check out his talk. I'll leave this QR code up for just another moment. Right now, it's on GDC Vault. We're expecting it to be up on other channels like probably YouTube sometime in the future too. Okay, then let's go ahead and start talking about Fortnite. So if you're not familiar with Fortnite, it is a lot of things. It's even sometimes been called a metaverse. But for today, let's focus in on the most popular and well-known game mode of it, which is Battle Royale. Battle Royale is, the whole thing is free to play. Battle Royale is third-person shooter. It's PvP competitive. And something that people might not realize is that we have a lot of online tournaments, and a lot of them have cash prizes. So we're talking about cheating, we're talking about online tournaments with cash prizes. If a light bulb just went off and you thought like, hey, I could cheat and win money in an online tournament, I'm sorry to say you're not the first one. We'll talk more about how we deal with this problem in the future. So what is it that cheats actually try to do in Fortnite? Basically, what they have in common is that they try to bypass the skill-based mechanics of the game. So what are the skill-based mechanics in Fortnite? Being that it's a shooter, aiming and shooting are extremely important. So getting good at that requires a huge amount of practice. You got to be fast and precise and coordinated. If you're using a cheat, you can use what's commonly called an aimbot and have the cheat just do that for you. So you can skip that whole process of getting good. And a lot of people would say that takes the fun out of the game. I would tend to agree. Unfortunately, not everyone sees that the same way. Another really important skill mechanic is situational awareness, or like game sense, more colloquially. You got to be really aware of the game mechanics so you can understand where there are likely to be enemies or unlikely to be enemies, and plan your movements and actions accordingly. Doing that requires a lot of experience. You got to understand the game items. In Fortnite, there's a lot of sneaky ways you can move around the map and stuff like that. There's a lot of brain work there, but if you use a cheat, for example, like what's commonly called a wall hack, your cheat can show you information about players that you shouldn't have, and you can sort of skip a lot of that skill element. So let's have a look at an actual example of a Fortnite cheat. This is some Fortnite cheat, which was detected, by the way. This one has an example over on the top right of like a wall hack. There's a player highlighted in red who's behind a wall that you shouldn't be able to know that they're there unless you saw them earlier and have game sense. There's also a circle near the center of the screen that is part of the aimbot feature of this cheat. So that's an example of a cheat. How do we categorize cheats? One of the ways that we can do it, there's a whole lot of options. One of the ways we can do it is just split them into free and paid cheats. This is one of the most simple ways. They both have some things in common. One thing they have in common is that there's a lot of scams and malware, especially on the free side, but both sides. Going beyond that, there's some more interesting and useful differences between the two. One of them is the update frequency. So free cheats tend to be sort of like dumped. People will usually upload them once and then rarely or never update them after that. And they don't do any kind of user support typically either. Maybe a forum thread, possibly. On the paid cheat side, assuming it's not a scam, they usually are very frequently updated. and they do support through channels like Discord or some other chat apps. There are one really interesting thing to know about free cheats is that they are sometimes actually outdated or pirated versions of paid cheats that are being distributed for free. Pirated cheat is kind of like a weird combo of words, but paid cheats almost always have some kind of copy protection or DRM, because if they don't, people will just use them without paying for them, which is a problem that a lot of game developers are familiar with. Happens to cheats as well. So in terms of what do I mean by paid cheats, how do they actually collect payment? They usually do monthly subscriptions. It's the most common way. Some of them do daily or weekly subscriptions too. But they will often operate in fairly professional ways. They'll do things like granting extensions to subscriptions if the cheat gets detected and they have to take it down for an update or something like that. So they're very much businesses. They're run like businesses. Unfortunately, they make a profit at the expense of legitimate players and developers. There's some differences in terms of technical methods too. For free cheats, typically the technical methods are much simpler. Usually if a cheater comes up with a novel cheat method that no one's used before and it's really innovative, they'll want to make money from it. So it'll go into paid cheats first, and then eventually those kind of trickle down into free cheats once they're more well-known. And generally speaking, with technical methods, paid cheats also, because of their update frequency and their financial model, they can do higher maintenance things. So for example, sometimes you'll see paid cheats that have, they only work on one CPU vendor, they only work on AMD, or they only work on Intel, or they only work on one specific Windows version, which is sort of like a neat signal that it's using some method that's very, very customized and heavy maintenance load. All right, so that's what cheats are trying to do. How can we actually discourage them from succeeding in this? Security is all about layers. Anti-cheat is no different. There's no silver bullet. There's no one thing you can do that will prevent all the cheats. You gotta have multiple layers, and hopefully that discourages attackers and also sets a time limit on their success. So if they have a cheat that's undetected and successful today, they should be in doubt about whether the same thing will be true tomorrow. So here's a few of the layers we do with Fortnite. One of them, is, of course, is Easy Anti-Cheat, which is part of EOS. That's for cheat prevention and detection. Easy Anti-Cheat works quite heavily at the system level, and it is about sandboxing the process and things like that. So to supplement that, this is something we recommend in our documentation, and I want to recommend to you here too, is having game-level anti-cheat efforts. For Fortnite, we have a small team that's dedicated to that. Some of the things that they do includes handling game exploits or cases where game clients are given too much authority. So those are things that Easy Anti-Cheat can't really solve, being that it's a general solution for cheating. That team does a lot more other things as well. Those are just a couple of good examples. Then we have player reports, which is very useful, as I alluded to before. Individual player reports are not very useful, but in aggregate, statistically, they're super useful. So let's go ahead and talk about these layers in more detail, top to bottom, starting with EAC. Prevention is extremely important for EAC. It's sort of like a foundational philosophy for EAC. There's basically two different ways you can respond to a player cheating. One of them is prevention, which is proactive. So that means, in our perspective, that the player tried to cheat, but it just didn't work. We don't punish them, and hopefully they just go back to playing the game normally and having fun. The other way you can respond is with detection, which is reactive. So that means that the player did cheat, you detected them somehow, and afterwards you punish them, usually with something like an account ban. So when possible, we think prevention is better because other players are not affected. It doesn't actually succeed, the cheating attempt, and you can avoid a negative feedback loop where the players oftentimes will go from having their account banned to just creating new accounts, especially in free-to-play games. And then the game for them becomes not playing the game and having fun, but rather ruining the game for other people, which is bad for everybody. How do you actually implement prevention? So we think about this in terms of limiting access to the game process memory. There are some other ways to cheat, but let's think about that for today. Doing this effectively on Windows really requires a kernel driver. And Easy Anti-Cheat provides that for you in a way that's well-tested and mature. As with everything, we're talking about layers, so no layer is perfect. There are limitations to this. One of the big limitations is that prevention is mostly only effective against free cheats because of the update frequency. So for cheats that are updated often, it's fairly easy for them to test and see whether their cheat is working or not. They can basically instantly know. They try to run it. It doesn't work, then they have to change something in their cheat, run it again. So for paid cheats that are updated often, detection tends to be more important because there's more opportunities to delay that feedback. All right, what else can we do? One thing that we started doing recently for Fortnite that is quite interesting is applying Windows security requirements for key tournaments. That, of course, includes ones where you can win money. What are Windows security requirements? There are a lot of optional security features in Windows that they're not designed to address cheating. They're designed to address malware. But as a nice side effect, a lot of cheats hide themselves in the same way that malware does. So these can make anti-cheat's job easier. And ideally, this should lead to a sort of win-win situation for us where we ask users to turn these on, and the result is that they become safer from malware, and our job becomes easier as anti-cheat. The specific ones we're requiring now for Fortnite are on the right there, Secure Boot, which helps address a lot of bootkit-style cheats that load early on in the boot process. And then TPM, which is kind of like a meta one. It helps us verify that other settings like Secure Boot are enabled in a way that's not easy to patch on the client. For the actual implementation, the things that we need there are knowledge on the game client side of whether the players are meeting the requirements and which requirements they are or are not meeting, so we can give them good feedback and say like, hey, your secure boot is not on, like here's how you should solve that. And then on the game server side, we need effective enforcement so that they can't just patch out the check. People who make cheats are very experienced with patching and manipulating game clients, so if you have a check that's just on the game client, it will not be effective. The implementation that we have is very, EAC is at the heart of it. These APIs are being provided from EAC. So this is sort of like a pilot implementation for us. It's not available for third parties at the moment. We're thinking about ways that we can make that available to third parties in the future. We think that this is extremely important going forward to have this kind of capability because it can help us give developers the power to decide when it makes sense to raise the security floor for their game, for example, in these tournaments. And doing that can also reduce the need for anti-cheats to grow their scope and, for instance, run at boot time or something like that. EAC does not run at boot time. Some other anti-cheats do. This allows Windows to do more of the work of providing that security foundation itself. Limitations, again, it's a layer. It's not the whole solution. These particular two things, Secure Boot and TPM, are supposed to be required for all Windows 11 installs, but they actually, there are ways to bypass that. A lot of people have done it. And vendor support is sometimes a little spotty for a minority of players. 90+%, everything works fine. But for a minority, there can be some problems that I'm sure will get better over time. But that's the current state of things. Then those were some EAC highlights. Now let's go ahead and talk about game-level anti-cheat in Fortnite. Whoops. So this is Unreal Fest. Fortnite obviously uses Unreal Engine. Let's talk about Unreal and cheating. One of the most important things to understand related to Unreal and cheating is reflection. So reflection is really great for flexibility. It lets you do cool stuff like look up objects by class name at runtime. But it requires a lot of metadata to be baked into your shipping binary in order to do that. That data, you're shipping your game client, obviously, to the public. So that info will be available to cheaters and reverse engineers. So let's have a look at an example here on the right. Let's suppose that I came up with a really awesome way to detect when anyone's cheating in my game as a game-level detection. And the only caveat is that it will only work if it's a secret. If anyone finds out that I'm doing it, then it will be blown, it won't work anymore. Surprisingly realistic for anti-cheat. So I hope no one finds this. I wrote this, just as I write Unreal C++ normally as a U function in a U class. So then let's go ahead and build our shipping binary and take a look at it. Oops, it's right there in plain text, the name of my function. So you don't have to be the legendary nation state hacker to find this. It's literally in plain text in your binary. What can you do about this? The most important thing to do is just understand that this happens and be aware of it. And you can do things like check the strings in your binaries and do diffs between different patch versions, for instance, to try and find out if there's data you're exposing that you didn't intend to. You can use plain C++ in your Unreal projects. You don't have to annotate everything with reflection macros if you're not actually going to use them. Obviously, people can reverse engineer your plain C++ code too. That's not really a great defense, but at least then they have to come up with their own function name and they can't know yours straight from your source code. Cool, then more UE considerations. RPCs are a challenge. So remote procedure calls, very foundational to Unreal networking and multiplayer. Server authority is very powerful in anti-cheat and just preventing certain kinds of cheats from even being possible. But it's really easy to get wrong. It happens to us at Epic. We add new stuff to Fortnite all the time, and sometimes mistakes happen. So I've got an example on the right, which is hypothetical. But there is, let's suppose in your game it's possible for players to fly in certain circumstances if they have the right equipment and they are calling it with the right timing, then they can fly. When you're doing testing and QA and stuff like that, you will have written your game client to only invoke this RPC at an appropriate time. So you might think that it's fine, everything's secure, but you have to be aware that cheaters are gonna mess with your game client. They're gonna make it call those RPCs at times that you didn't intend. So you should write your server with the assumption that your RPC is getting called at arbitrary times, and you should do whatever verification you can. So that means, in this case, like the server knows what equipment the player has, in my example case here, so it can check, and it should check that the player has the right equipment. It should check that the timing is correct and the player's not calling it more frequently than should be allowed. Another thing that we do at the game level, but not in the game code itself, is work with the community. So we find that being open to community help with security issues helps find more issues and fix them faster. One of the reasons why is that every company, every organization has its own security culture and its own perspective on what the high-risk areas are. Outsiders will have a different perspective. They'll look at different things than you do, and they'll find issues that you don't. So it's valuable to hear that. How we actually implement this with Fortnite is we have a HackerOne program. HackerOne programs have scopes. Part of our scope for Epic and Fortnite is including novel game exploits and cheating techniques. So novel is kind of key here. You will get people who send you low effort crap that's useless, but you want to set the expectation for that. You're not going to give them money, but if someone sends you actually novel and useful information, then there's an opportunity. So these reports from security specialists are really useful, but average players should have their say too. Which brings us back to player reports. Again, individual player reports are useless, but in aggregate, they're very helpful. Developers will often ask us if they should make it so that player reporting is a little bit more difficult because they're worried that players will spam them. I want to give our take on that in Fortnite here. On the right there's a screenshot of the view you see after you've been eliminated in Fortnite. It's maybe a little bit hard to see here, but our report player button is right there in the bottom left. It's like literally exactly the same size as the main call to action here, which is continue on the bottom right. So our take is that don't fear the spam. Everything is statistically based. Make it easy for players to report. You don't have to bury your report button 3 levels deep in a menu. It doesn't help because you just want to look at changes over time and statistics and things like that. And the two real values that you should get out of player reports are, one, you can highlight players who are suspicious, but they're not getting any sort of cheat detections, and that can help find undetected cheats. And two, you get sort of a metric on perceived cheating in your game over time. Player reports can certainly, they represent perception of cheating. They don't represent the actual reality of cheating necessarily in your game, but it's still valuable to understand the perception. That's enough about Fortnite. I will hand it over to Thomas to tell us more about 2K's experience.
Thank you. So let's talk a little bit about game security at 2K. While this is a very broad topic, starting with anti-piracy, anti-fraud, toxicity topics, profanity in the games. When we talk about anti-cheat, this is about the fairness in the game. And so our focus there is by developing an in-house anti-cheat system, which is on user mode, to, what Rick said before, prevent the harm before it's done. And as always, there's like no silver bullet. So we also rely a lot on player reports. The community cares about our franchises, and they reach out to us actively over customer service and are reporting, hey, here's a new cheat tool, here's a new exploit. So we are listening to that, as well as like in-game reports, which are like similarly handled, like we have seen in Fortnite before. So we also have a similar strategy here, going the statistics afterwards. And saying, this is the customer base, this is the player base, which are reporting oddities, and we're investigating that further. And last but not least, for our more competitive titles, Easy Anti-Cheat is also an important piece to the puzzle for our anti-cheat strategy. There's no one size fits them all. We have a variety of titles from competitive, from our sports games, over simulations, to pure single-player experiences. So our strategy is to sit down with producers, to sit down with each studio, and then discuss the right set of tools and focus, which makes sense for the title. And in the end, we put here, like as a player advocate, our head up and say, hey, what does a player actually experience when they play our game? And if it's a pure single-player title, Mafia, for example, coming up in some weeks from now, if someone is changing the gameplay to their liking and it has no impact on the fairness of the game, we don't care. As soon as it's impacting others, and that starts as early as leaderboards, but especially in PvP, we do care, and then we take the right measures, again, as much as possible, being proactive to prevent the harm before it's done. And only as a last resort, think about sanctioning and banning of players. So especially in live service titles, like many of our sports titles are, before we remove a player from our ecosystem, we think twice and three times how we can keep them engaged with the title, but in a fair way. Why is anti-cheat challenging? Well, multiple topics. As I said before, we don't have just one title. We have many titles, and they come with different engines, they come with different game features, they come with different game modes. So we have to carefully select the right measures to prevent cheating. And some things are super generic. We heard before about the free cheats and the paid cheats. Usually what we experience in our titles is the free cheats are like tools which are used across the board on many titles. And then there's just some specific scripts or cheat tables or whatever being provided for the individual titles. These tools usually don't react in any kind of anti-cheat. There's no business model behind it. The community out there, or even if the tools are open source, are rarely reacting to proper anti-cheat measures. As soon as there is a monetization in the game, there's always this blend over between cheating and fraud, which we are seeing a lot on the paid titles, which we have to then tackle on both sides in the interest of our monetization, but also in the interest of keeping our game fair and the players engaged with the title. So for the paid cheats and also those which are having this freemium model, so you get 2 features of the cheats and for the rest you have to pay. We have seen that those cheats which are trying to support thousands of titles, they do not react to proper anti-cheat strategies. It's just too much effort for them. They rather add 10, 15 new titles a day instead of investing a lot of time into a single title and maybe have to update on a weekly basis or monthly basis how often the title and the anti-cheat is updating. The other thing we have seen is like with us ramping up the game on the anti-cheat side, also the cheaters are ramping up the game. So I mentioned before that we are in user mode. Easy anti-cheat is in kernel mode. So what we are seeing is that more and more of the cheaters are investing heavily into cheating and are actually then buying hardware cheat devices, buying DMA cards, etc. To continue to cheat. We're talking about hundreds of dollars investment, and that also means that on the grand scale, we are winning. So if you have no anti-cheat strategy, 100% of the player base could easily cheat with free tools. As soon as a proper anti-cheat strategy is in place, tons of those cheaters are going away, enjoying the game as it's meant to be enjoyed, and only a very small percentage of the cheaters are actually continuing with like high price investments into their hobby or whatever you want to see it. Also, like when we look at shooter titles like Fortnite, what we've seen before, there's like a handful of standard cheats, which is here's like a trigger bot, here's a wall hack, and so on. With our titles, especially in the sports titles, we are seeing that they are very tailored to each game mode, and we have dozens of game modes. So it's not that easy that we can nail it down to one specific behavior and one specific cheat attempt, but we have to like work actively with the studio, understanding where the vulnerabilities are and trying to be as proactive as possible to make it as hard as possible to cheat, but also like think about proper detections so that we can sanction those players which do not want to learn. How we use EAC. For us, the approach, how EAC is actually booting up in the game, so it's not like booted up with Windows, but only when the game starts. This was like an important topic for us to be least invasive to the player base. The process isolation is a cornerstone of the strategy when we say we want to be proactive. So process isolation is actually preventing other processes to write or read and write to the memory of the game, which is getting rid of like many of the standard cheat tools out there, trying opening a handle and doing something in memory. And the second part is also like that based on those tools which bypass that and patch the memory, that we get that telemetry data. And Rick mentioned before that everything can be done in the back office of the Epic Online services. We do leverage our own tools and seamlessly integrate it into with the EAC API to consume all relevant data for us and marry that with our game telemetry. We always look at how can we keep a player engaged with the title. So the important thing for us is to get players who misbehave the chance to actually learn and do it better next time. And on the other hand side, we do not want to give away the tactics of and how we actually detect someone. So the strategy which we are having is we do like regular ban waves, and in that way the cheat tool developers cannot easily probe how we detect what they are doing. They don't know, is it easy anti-cheat which is detecting, is it our in-house anti-cheat, or is it a player report which we analyzed and deemed as ban-worthy or sanction-worthy for that player. And yeah, there's obviously a lot of speculations, and we get the direct feedback for our work in all the cheat discords out there. So it's always fun to read after a ban wave. And they're like, oh, this was like a pure player report ban wave, because they want to emphasize their user base that all their cheat tools are undetectable from a technical perspective, which might or might not be right. So yeah, this is how we overall try to obfuscate from a psychological level on how we detect and then sanction. We also have a close loop with our customer service team. So whenever someone is appealing, these appeals are reviewed. And yeah, 90% of the time it's usually the little brother who did the cheating. Yeah, this ensures that we don't have any false positives, or that we can correct any kind of mistakes we have done. What's happening next? Well, I mean, it's a cat and mouse game, right? So we ramp up the game, the cheater's doing something new, so it's always going back and forth in that area. I mentioned DMA cheats before. I mentioned hardware cheat devices. So these are the focus areas for us, as most of the tools which are running on Windows, just attaching to the game process, have been ruled out over the last months and years with the strategy I mentioned before. Again, being proactive as much as possible, and for those paid cheats, being reactive is usually the better approach, as we if we put the countermeasures in the game client, it can be easily probed and debugged. And if you have a silent detection for those, it's ways more efficient. Yeah, and last but not least, in the end, the goal of each cheater is to be better than average, right? So the question which we are then having is, what's the benchmark? How good is a good player, and what is inhuman behavior? And these are areas which we are currently looking into with machine learning models based on inputs from mouse, keyboard, controllers, platform agnostic, to see if we are able to detect cheaters purely by their input, and make good predictions of who's a real player and who's a cheater. Thank you, and we are open for questions.